So welcome again. Thank you for joining this webinar on threat detection with Falco. And this is how presented we are trying to do for various meetup groups which you might have joined based out in the Bay Area, but being remote, virtual, it can be anybody joins from different places. We have got people from all parts of the country joining in several of the things. We did a very big Google Dev Fest a few weeks back. So that was amazing on the Google campus in San Jose. And we're continuing the series trying to be at least in a monthly one frequency to bring the knowledge and experience with experts from the industry. My name is Raju. I'm your host. And I'm also part of this team called CloudOpti, a product. So we just wanted to give a quick shout out on this one slide. CloudOpti is a cloud platform, SaaS platform for cloud optimization, considering 4 different pillars where we optimize on the parameters of cost, performance, security, and compliance. We work on AWS as well as GCP. And on top of it, we have a very unique solution which has a cloud score, similar to something which you have a credit score in US, similar to that, to gauge how your cloud is optimized. A unique number is trademarked. We have it, not the official ones. I think it's a great concept, a unique concept, which helps you refine back and forth. So as you improve your score, these pillars improve, or you improve the pillars, obviously the cloud score improves. That's a concept. It's a SaaS-based platform. You can sign up for free for going to cloudopti.com. We'll share some details in the end. But that's a quick shout out. But with that, we'll move to the main agenda for today. Mike Coleman is the speaker. He is a staff advocate, developer advocate at Sysdig, but he has a great career behind him before that as well. He's been an accomplished visionary product manager and marketing professional with various tech companies, big names in the industry for a long period of time. Exceptional background in strategic projects, sales, marketing, long and short range of tactical planning, business development, a whole range of things. He has already worked in big names companies in the tech side, AWS, Google, Docker, Puppet, VMware, Microsoft, and Intel. And now he's working in a full-time staff developer advocate in at Sysdig. The agenda or the idea for this, I'm sure Mike will talk more, but briefly it is to really use Falco and be explaining more of that to how to really improve the cloud security posture or just security posture and threats in general. So with that, welcome, Mike. I would love to really hand the floor to you and
all right,
take over the share. I'm going to stop the share and the floor is yours.
all right. Oh, that's not, what are we? That's the wrong one. Hold on. Okay. All right, there we go. All right, you don't need to see my Christmas shopping list on my Gmail. That's what that was. Anyway, yeah, so thank you very much. I'm Mike Coleman. I'm a developer advocate at a company called Sysdig. We're a cloud security platform, cloud native security platform. And core to our platform is an open source project and component called Falco, which is what we're going to talk about today. I am full-time focused on the open source project, so I don't really get involved with the commercial business very much. So I'm not going to spend any time selling to you today because I don't really know it that well. We will talk about, sort of how runtime security fits into the larger security and cloud native security picture, but that is, we'll get into that. So yeah, kind of a brief overview. I joined Sysdig earlier this year, coming over from Google, where I worked on the advocacy team for GKE. Before that, I was at AWS. Before AWS, I was at Docker. I spent a little bit of time at Puppet. And then before that, I spent a bunch of many years at VMware and at Intel and Microsoft. So I've been around a little bit, which is good because that's how we kind of talk through the runtime security and what it is and why you need it before we get into the technical details. So we're going to start with a sort of a landscape, an overview, a history lesson. Then we'll dive into what Falco is, the architecture, how it does what it does, the rules engine, the state engine, and then we'll talk out about how you can extend Falco to be able to use it in your environment using tools that you're probably already using. And then closing remarks is basically just a recap of the first 3 bullets, because apparently that's how you structure an effective presentation. So All right. So I mentioned that I started, I was at Microsoft. And when I was at Microsoft, actually, I was a sales engineer selling Windows 2000 and into data centers, right? And this was kind of where, before all that, before that Microsoft job, actually, we didn't really talk about it. But when I was at Intel, actually, I was the site IT engineer for all their Oregon campuses. So I was the lead IT architect for them. And we were at a point where we were making x86 boxes. So we started making x86 servers, right? And this is like Windows NT, Windows, Novell NetWare, all that. And these servers, they kind of were like a novelty, right? Most stuff ran on like AS400s or mainframes or whatever. So we basically we had these boxes that they would take kind of a long time to get. Even though I worked at Intel, right? It would take us months to get servers. We would put them under someone's desk. Maybe we'd put them in a closet somewhere. We would kind of back them up. We weren't really utilizing them very well. Now, of course, through time, the adoption of x86-based servers became more prolific, right? But those problems persisted. You didn't have an easy way to document what was running on your system. You didn't really, you needed to allocate space in a data center. It became very difficult to sort of manage them, especially as we got more of them. And then, after that, I actually went to work for VMware, right? And what we did at VMware was, we created this idea of a virtual machine. Well, we didn't create it, but we kind of popularized it. This idea of like, okay, let's take now, instead of being able to have to run your email server on one server and your file server on another server and your database server on another server, if we put them inside of these isolated virtual environments, we can run them all together, right? We can all run them on the same hardware. So the first thing we did was basically reduce the data center footprint by about 30 to 40%, right? And that's because we were able to, really take advantage of the processors and the memory on the servers rather than having them highly underutilized. It also made it much faster to deploy things. It says here days, depending on what you were doing, it could be days to build a VM and get it all tuned up right. But it was way easier than just plain old vanilla servers, right? And some of the issues though, right, were that you still had this like idea of running multiple instances of the operating system or the kernel. So in a virtual machine, of course, it's a full-blown copy of the operating system. It takes several minutes to boot up. They're usually pretty big. There's not a lot of isolation between the application and the kernel. Once you're in that virtual machine, you are sort of on the host and you have full access to everything there. Which is, could be a bad thing from a security perspective, right? So then I was at VMware for a while, and then I left there. I went to Puppet for a couple of years, and then I went over in like 2015, and I went over to work for Docker. And that was sort of where, Docker didn't invent, again, like VMware, they didn't invent the virtual machine. They didn't invent the container, but they made it more accessible, and they solved some problems. Containers were designed to solve, in particular, one problem, which was it doesn't run on my machine. So what they do, if you're not familiar with them, and I'm going to talk about them from the Linux perspective, they do run on Windows. They function the same, but the way they're implemented is different. So we're going to talk about the Linux side. Basically, containers are isolated Linux processes using things like C groups and namespaces. We're able to take any process running on Linux and make it think it's running in its own environment, its own standalone server. So you take all the application and all the dependencies, you package them up into a container, and you can ship them around, right? You have the container runtime, and wherever that's running, then these containers will run. So I could write code on my MacBook. I could send it to QA, who was testing it locally on some, in a local environment in the data center, right? And then we could deploy it into the cloud and not have to worry about it not working. The other thing too is it allowed people to start breaking their applications up. And containers are much smaller than virtual machines. And they basically, now we're looking at it and we're saying, okay, so I'm going to run my Apache web front end in a container, and I'm going to run my business logic, whatever, my shopping cart management, whatever it is, my payment processing, catalog lookup services, all of those are going to be their own containers. And then my database may or may not be in a container. Maybe it's a cloud-based database like Cloud SQL up on Google Cloud. And now I've got, like, instead of one big application, I've got 3 different services talking to a cloud-based service. All of those could be scaled independently. They could be developed independently. They could be deployed independently. So now companies went from deploying, maybe weekly, monthly, or quarterly to like deploying multiple times a day. And again, like VMs, they took the resource efficiency to another level because they're lighter weight and they're smaller. But all of that sort of led to a set of problems, right? And this is, getting into why we need the runtime security, right? So microservices containers are great. You've got these loosely coupled components and you can write them in whatever language you want to. You can scale individual services, all of that. But the problem is you went from having one monolithic application, and maybe if you were if you were running a production, you would have like some web front ends behind a load balancer talking to a database, and you could scale those load balancer servers. But you were talking, if you were big, you were talking dozens or hundreds of servers. Now we're talking about the potential for thousands of containers, and not just this sort of monolithic container, but you've got a web front end and you've got business transaction and all that stuff. So now you've got thousands of containers running in production. You got to figure out how to get them onto the systems you need them on, what to do when they fail, and that's where Kubernetes comes in. So Kubernetes is a container orchestration platform that was born out of Google, and it basically does a few things, right? You basically tell Kubernetes, hey, I want to run this web front end and I want 100 copies of it. And so it goes and you've got this Kubernetes cluster with 5 servers, 10 servers, whatever it is. Kubernetes will be like, okay, well, I'm going to put 5 of them here, 5 of them here, 5 of them here, 5 of them here. And it's going to deploy them out, and it's going to do it based on a bunch of complex rules if you want to. And then if one of them fails, it's going to start a new one up. If you need to do an update, you can deploy a new version, and Kubernetes will help manage the rolling upgrade process. It makes managing containers much simpler. Now, that being said, Kubernetes is a very complex piece of software, but it's widely adopted. I was at KubeCon in Chicago. There was something like 20,000 people there. When I went to my first one in like whatever it was, 2014, 2015, 2016, somewhere in there, there was like 800 people, right? So in the last 7 years, there's been this enormous growth of adoption of Kubernetes. It's sort of the de facto standard if you're going to do containerized workloads. So it's managed by something called the Cloud Native Computing Foundation. I don't know why the slide's in here, but we'll cover it real quick. So whenever we released Kubernetes in 2015, then the Cloud Native Computing Foundation was founded, and it deals with all of sort of cloud native technologies. And projects get donated to the CNCF to ensure that they have good stewardship, that they're of appropriate quality, that they have a path from sort of this idea phase to a release candidate phase to a fully production ready phase, right? Sandbox, incubated, graduated. So CNCF it takes care of all of that for folks. Now, I already kind of covered this. So why did I take you on that history lesson? Because security changed the same way, right? So if you go back to when we were at Intel, our security was really about keeping people out. It was about a firewall, right? That was it. Like, okay, we're going to guard the perimeter, and if we keep people out, then we aren't going to have any problems, right? And I think there was obviously people that took security a little deeper than that, but that was sort of the general paradigm. The paradigm was guard the perimeter and keep people out, and when they come in, then you have a problem, right? And this was, of course, we learned there was a lot of ways to get through into the environment that didn't include going through your firewall, right? Like CDs and rootkit and that kind of stuff. But this is where we started. Where we are today, though, we don't have a defined perimeter, right? There is no perimeter that you can just wrap up neatly. You may have a data center, you may have applications running in the cloud, you may have multiple different teams. This is if you think about cloud native security and cloud security in general, there are so many layers of security. There is the, authentication authorization layer, IAM, there's the network policies, there's how you define your VPCs, there's how you secure communication between services, there's, virtual private clouds and how you manage them, and how you connect back into data centers with virtual private networks or dedicated lines. There's all of these different points where you need to secure it, and all of these different points where it can go wrong, right? I had a person talking to me that, that we were conversing during a presentation, and the person said to me, the biggest risk to my environment is a disgruntled employee. And I was like, I actually don't think it is. I think the biggest risk to your environment, the thing that will cause the most danger, the most opportunity for attack, is an overworked system administrator who takes a shortcut, or a developer who doesn't actually, think about what they're doing, and we just make a quick mistake. I have pushed my AWS keys up into a public GitHub repo before. I have gone out and set up a service account, or an IAM role for a service I was deploying, and said, just give it full access, right? And I've been called out on that, right? And rightfully so, but I wasn't trying to make a mistake. I wasn't trying. I was just, in one case, I was just following documentation that should have been updated. In another case, I just made a mistake, right? I didn't scrub the repo before I pushed it up into GitHub. And so those type of behaviors, when we're tired, when we're rushed, when we're still gaining knowledge, it's those mistakes that open us up to security breaches. So what you need to be looking for isn't the breach. You need to be looking earlier for the activity that leads to the breach, right? You need to look earlier for behavior and operational anti-patterns that are what is going to allow somebody to come into your environment, right? So, and if, I kind of touched on this, but if you think about all the areas where, this sort of protection needs to apply, you need to make sure that your data is that where your data is, that who's accessing it. You've got to be able to scrub through different logs and monitoring systems. You've got IAM rules to worry about. You've got network policies. You've got to actually secure Kubernetes itself, which is a whole nother thing all by itself. Your workloads need to be secure. So are people deploying code with CVEs? Are they common vulnerabilities and exploits? Are they running containers? Is it serverless? And then all of the stuff below that, like all the cloud stuff in general. So all of these areas, need to be looked at. And so what the industry has come up with is something called a cloud native application protection platform. And cloud native application protection platforms, and that's what Sysdig sells. We have a platform that does this stuff. They basically try to attack security sort of horizontally and vertically. Horizontally, to me, is as we move through the software development lifecycle, how do we ensure that security is built in from the very beginning? A lot of people call this shift left. So this is the idea of I'm going to be looking at my dependencies. I'm going to be looking at all my containers. I'm going to be scanning these things. I'm going to be looking for known problems, and then I'm going to get those remediated even before I push the code into sort of the final stages of the development. Before, we used to sort of build code, and we would be security conscious, but we would just be like, oh, I'm grabbing this package from npm, or I'm going to download this thing with pip, and not always with the best hygiene. And so these tools help automate that hygiene for people. And then network security and posture and compliance, did you, and so this cloud security posture management, it's cloud identity and entitlement management, monitoring, those sort of things. That's all about how am I provisioning my IAM roles? How am I assigning roles to principals? How am I auditing all of that? How am I taking care of all of that and looking at that? So that's a big component. So that's sort of okay, I've written secure code, but how do I know where I put it is actually secure? And then the last is sort of this idea of protecting your code out in GitHub, out in the world. And that sort of infrastructure is code security. So how do we know that people aren't pushing secrets into public repos, that sort of stuff? So CNAPs are very, I mean, they're very all encompassing, right? It's sort of this big, wide ranging set of tools. So if you have all that, then why do you need runtime security? Well, runtime security is an additive component. Everything I sort of talked to you about was sort of like config checks and static analysis, right? It's looking at libraries, it's looking at roles that have been defined, it's looking at accounts and how they're being accessed, it's looking at network policies and TLS and all of that stuff. And that's all extremely important. But what happens the day after you deploy your software? So if you build an application on Tuesday and it's all secure, and then somebody goes in and they change something in the operating environment that they weren't supposed to, how do you know that? And all that work that you just did doesn't really matter, because now you're running in an unknown environment. And so that is what we're looking for. We're looking for pattern analysis, behavior analysis, things that would be indicative of environments that have been potentially compromised. And as I said, it's additive. So, it's really about taking care of things that happen, after that initial deployment, vulnerabilities that are discovered later in the wild, that sort of stuff. I mean, if you look at something like Log4j, that vulnerability was introduced in 2013, but it wasn't discovered and reported until almost 10 years later. So that's a really extreme example of like, oh, I thought I was great. I've been using this thing for 10 years and I didn't even know it. Now it's deployed everywhere, right? And people, had to scramble to try to patch and figure out if they were running it or not. So that's where runtime security can come in. So, Gartner is an analyst firm, and they're probably the most respected one. Their take on it is you can't just secure the source, you have to secure it all the way through, and you have to have real-time runtime visibility into that environment. So we kind of take that approach, and we, going on with the analogy of the perimeter, if somebody's already on the inside or they've gotten past the perimeter, well, how do you know? Well, security cameras are on all the time. They're always looking. They're looking for people that are in places they shouldn't be, for things that they're people doing things they shouldn't be doing. And they can then pass that information on to the security team, and they can take a look at it, right? So that is what we talk about with Falco, is this idea of a runtime security camera that can provide sort of end-to-end detection, right? We have to make sure that the code up in the repository is secure. We have to make sure that the identity providers that people are using are secured. We have to make sure that the cloud services that folks have been deploying their software to is actually in good shape. And then whether that's in a container or running on a host, serverless containers, Kubernetes-based containers, or on a host, that while it's running, we know what's going on. And that's where, we can look for things that I've mentioned, like this idea of pushing credentials up to GitHub, or did somebody go in and run a privileged container, a privileged pod in Kubernetes, right? When they didn't really need to, did they go in and did they log into the AWS console and they didn't have multi-factor authentication on? Or maybe you're using something like Okta for single sign-on, and you notice an account has been, they failed their multi-factor authentication a bunch of times. Those things are not necessarily in and of themselves breaches, but they are things that can be indicative of a breach happening or that could lead to a breach, right? So that's what Falco is designed to do. So Falco is an open source runtime solution. It runs on Kubernetes, it runs in containers, it runs directly on hosts, only on Linux today and for the foreseeable future, but you can run it at the host level, you can run it in a container, you can run it as a daemon set on Kubernetes, and it'll protect all of those different environments. So we are an incubation level project. We have applied for graduation. The vote has happened by the technical committee. So we're dotting our I's and crossing some T's, and we hope in the not too distant future, we'll actually be a graduated project. These slides, I keep meaning to update it. We have about 80 million pulls now off of Docker Hub and 6,500 GitHub stars. We're being used by big companies. We have maintainers on our staff. Many are from Sysdig, but we have some from smaller vendors, but we also have Melissa from Apple, for instance, who's a maintainer. So that could, Apple doesn't like to talk about the software they use, so I'll let you infer what you will out of that. So Falco by itself is actually pretty simple. It takes inputs, it processes them, and then it outputs an alert. And then the process, is where we look at the behavior that's being done, and we compare that to a set of rules. So for inputs, we have natively Linux system calls. So we will be looking at every system call being made by the host operating system, and we will be bringing that in and looking at it. Now we can also, through a plugin architecture, which we'll talk about later, we can hook up things like Okta logs or AWS CloudTrail logs or Kubernetes audit logs or Google Cloud audit logs. And they can become input sources as well. GitHub can be an input source. Then we take those and we process them, and we enrich and filter them. And we'll get into what that means. But basically the filtering is like, do I have a rule for this? And did you violate it? And the enrichment is, okay, let's go and get as much information about this actual event so that when we alert you, you have enough information to take action, right? And then we output by default to standard out syslog and syslog sort of on the host, or in the container, depending on where it's running, as well as to gRPC and HTTPS endpoints. So you can programmatically access this event feed as well. And we also have, just like we have a front-end plugin architecture, we have an extension on this called Sidekick, which we'll get into in the ecosystem that lets you build this list out to all kinds of different platforms. So but out of the box, sort of default, system calls, enrich and filter, out to standard out or syslog, right? That's where stuff goes. So how does it actually work? How does it do what it does? So Falco has a kernel driver that is capturing all the system calls, right? So that kernel module can that driver can either be a kernel module or an eBPF probe. So if you want to modify the behavior of the Linux kernel, you can do it sort of, there's sort of three ways you can do it. One of which is to actually submit a patch to the kernel and go to the Linux Foundation or whoever and say, hey, I want to patch the kernel, and I want to patch the kernel. So every system call gets written to a ring buffer, and they will look at that, and they will probably be polite and not laugh at you until you leave the room, but they're not going to patch the kernel for you, right? So they said, okay, but we've got to have a way to modify kernel behavior. Well, so the first way to do that is with kernel modules. And kernel modules are loadable, and they basically modify the kernel for your environment, and they can do whatever you want. So we have a kernel module that captures system calls and writes it to a ring buffer. Kernel modules are great, but if somebody writes a bad kernel module, it can take your system down because it is running at the lowest level of the operating system. And then there's eBPF probes. And I have a slide on eBPF, so I'm not going to get into that just now, but we will get into it in the next slide. So whatever you use, kernel module, eBPF probe, those events are written to a ring buffer. And we do this because we want a non-blocking operation on this particular step. So syscall comes in, the driver grabs it and just throws it on a ring buffer. It does not care. It does not care. Now, the ring buffer can get full, right? So if you picture it as a ring, right, if there's 100 entries on it and it gets filled, the 101st entry is going to replace the first one. And it's just going to go on a rotating basis. The ring buffer can be sized for whatever size you want it to be. I think with the kernel module driver, the default size is 8 megs. And then I think for the eBPF, because you can assign it per CPU, it's 2 megs, and then you could do it per CPU. I think I got that right. So the ring buffer is in kernel space. All that's happening in the Linux kernel. And then out in the user space, we have a Falco daemon running, right? And this can run in a container. It could run on the host proper, wherever you want it to run. And that's doing all the heavy lifting about maintaining system state, parsing out the events that we care about, checking if they match a rule, and then adding a bunch of metadata before sending the alert out. And we'll dive all into that in much more detail here in the upcoming slides. But that's the gist, right? Capture events at the kernel level, throw them on a ring buffer, and then read them in and deal with them. So I want to spend a little bit of time on eBPF because eBPF as a technology has become very popular the last few years, which is great. It's just interesting because it's something that we've had in Falco for years and years. And it's basically another way to interact with the kernel. It stands for Extended Berkeley Packet Filters. Berkeley Packet Filters were originally designed to operate at the kernel level and filter out network traffic. And then someone said, well, if I could filter out network traffic or direct it, or not just to filter it out, but to manage it, filter it, redirect it, whatever you want to do, monitor it, whatever you want to do. So they extended that, and now it basically can read whatever it wants out of the kernel, but it does it in a different way than kernel modules. So you write your eBPF code in C++. There are some wrappers for other languages, Python, for instance, and you write that code, and then it's going to get sent down to the eBPF module, and that is going to compile it using a just-in-time compiler into bytecode. And that compiler can do a bunch of tests on the code and ensure that the code being deployed is of the highest quality and not going to endanger your system. And then it can run in an isolated space so that if something does go awry, it doesn't affect the rest of the kernel. So eBPF probes are they are much lower overhead. They're more secure. They're just generally a better solution than kernel modules, right? It's a simplified way of getting in and instrumenting the kernel. We actually have two eBPF probes. We have the eBPF probe and the modern eBPF probe. The eBPF probe is for older kernels. So if you think about it, which one should you use? You should always try to use the modern eBPF probe. And that's for the latest versions of the kernel. It's for cloud providers. It's for things like Minikube. It works on all of them. And the nice thing about that is it's pre-compiled and it just works. When you download Falco, it's already there. You don't need to load the driver. You don't need to go looking for it. It's just there. So that's the modern eBPF probe. The eBPF probe and the kernel module probe both get compiled for the distro and the version of the kernel they're on. And we pre-compile dozens and dozens of drivers, but if we don't have one, right, then you'll have to do it yourself. So when you install Falco, it basically goes in and it has a component called the Falco driver loader. And the driver loader is going to go out and it's going to look for a precompiled kernel driver for your system. If it can't find one, it's going to try to build it itself. It's going to try to just build it based on what it knows. If that fails, then you actually have to go off and build that driver yourself. The vast majority of the time in sort of mainstream production systems, we're going to have you covered, right? Either with the modern eBPF probe or eBPF or kernel module. That there's going to be an option there that's pre-made for you. You don't have to worry about it. But there are instances where you do kind of need to take it upon yourself. So that's how you get the driver into the system. We talked about this. I talked about real quickly about enrichment, and when you get I took a slide out. Hold on, let me see if I can find it. I took this slide out, and now I realize why I had it where I had it. Or maybe I deleted it. Oh, well, I deleted it, so it doesn't really matter. Let me see. We do this as a 2-hour workshop, hands-on workshop too. Yeah, this is the slide I wanted. So this slide here shows you Falco output. right? So you get notice, a shell was spawned and an attached terminal. And then you get all this information about the login user ID, the container ID, what shell they ran, what was the command line they ran, what was the terminal, what was the image that did, that it ran. Same thing here, right? So netcat ran inside, and that could allow for remote code execution. We're going to give you the username, the command that they ran, netcat-e, what container it ran in. All of that data is what we get through something called enrichment, right? And this enrichment process is it all goes under the covers, but basically, let's take a file system as an example. So we will monitor activity on files. Like, did somebody open a file that they shouldn't have? Did they write to a file they shouldn't have? Has a systemd unit file been changed? Has somebody gone into Etsy password or Etsy shadow? Those sort of things. So, but when you work on a file, so you're going to write some code, you're going to say open file.txt, right? Or you're going to say cat file.txt. What's going to happen is the very first system call, not the very first, but the first one sort of related to the file, is one of the first ones is going to be open. And it's going to be open file.txt, and that's going to return a file descriptor. And from that point on, the operating system never looks at the file name again. So if we're monitoring write calls, and then you're going to say write some string file descriptor 3, right? You're not going to say which file it is, you're going to say file descriptor. So if we capture that system call, we don't know what file you're writing to. We have no idea because all we have is the file descriptor. That's why we have to maintain state tables in Falco. We have to be able to quickly map information about different processes into together. So if we were going to do this manually, we'd have to go from the file descriptor to the file table to the inode table to be able to figure out what file descriptor 3 was, right? And oh, by the way, that doesn't really, that means going to disk. That means being really slow. And so we just don't do that. What we do is, as I mentioned, is we maintain something called a state table. So for every process, as system calls are coming in, we're building tables in memory to be able to quickly access information about those processes, like who ran them, what was the command name, what container did it run in, a table of file descriptors it's using, what those file descriptors refer to. And we do this because we monitor not only system calls, but we're also monitoring, in the case of containers, Kubernetes and the container runtime. And so that's why we can get things like what pod is it? What container is it? What's the name of the container? What's the ID of the container? All of that stuff gets married in. And that's where we go back and we get the enrichment aspect where we are able to go through and look at what, and provide you meaningful information on what is happening in your system. So Falco detects something, it puts it on the ring buffer, it pulls it in. I should have done these slides in the other order. And then it goes in and it says, okay, well, do I have a rule that I care about? So we ship with over 80 different rules, and they're all up in our GitHub repo. And they deal with things like, did somebody run a container with a privileged pod? Did somebody execute sudo in a container shell? Did somebody, is somebody writing information into user bin? Which would be indicative that somebody's trying to copy a payload in that didn't exist on the system. Did somebody try to shell into a running container, right? Like, that's not something you should do. So is somebody accessing your running environment through sort of a back door, and if so, what did they do there, right? So we can notify you of, like, that you saw that netcat warning, right? Somebody is in a container and they run netcat, we will alert you and say netcat was started. If somebody shells into the container, we will tell you that. If somebody goes in and does, let's say they get in, they do a wget, they bring down some piece of code, or they do apt-get. So yes, if you run apt inside of a running container or any package manager, yum, RPM, whatever it is, we will notify you that somebody's running a package manager in your running container, right? That's not something they should do. Now, if they do that, let's say they do that. So they do apk add nmap, and then they go in and they say, let's move nmap from /user, /user space, whatever, nmap to user bin app. and they're trying to make nmap look like some other piece of code on your system that you expect to be there, we will notify you that if people rename files, if they create symbolic links. We want to be able to show you things that are happening in the environment that aren't by themselves necessarily bad, but they could be indicative of something bad. Sometimes they're just flat bad. If somebody's running netcat, that's probably a bad deal. You probably want to investigate that straight away. So the rules have a, actually, I'm going to go back to my other slides because my other slides are better for this. Maybe I'm not. Okay, never mind. I'm just going to stay here because I think I lost them. Okay, so the Falco rules are really easy to read, right? This is the rule name, the description, and then a condition. Falco rules are all Boolean conditions, right? Did someone spawn a process? Is it in a container? And was it a shell process? Yes, yes, and yes, right? Someone spawned a process in a container and it was, not a shell process. Okay, well, I didn't violate the rule. It was a spawn process. It was in the container, but it wasn't a shell process. So we don't care. So for this rule, we don't care. And then this is that metadata, right? So user.name, user.login ID, container info, right? All of that is stuff that we pull from that enrichment data to be able to give you a set of rules or a set of outputs that you can take action on. And, like, for example, Etsy shadow is considered a sensitive file. So if somebody runs if somebody says cat Etsy shadow, then you'll get an alert on that. If we didn't have the enrichment data, you would get cat. Well, first of all, we wouldn't be able to write the rule really effectively because we wouldn't know what file they opened up potentially. But if we did, we would just have the file descriptor, and that would be problematic. So you will notice though, like here, we had that thing spawn process and container and shell proc. Those are examples of macros and lists. So these things allow you to sort of reuse your code, right? So how do I know if something's a container? Well, the metadata container.id will say host. Otherwise, it would be the ID of the container, right? If it's not in a container, it's running on the host and the container ID is host. So if it's anything but host, I know I'm running in a container. How do I know that I spawned a process? Well, the event type is execve. Execve is the system call for starting a new application. And so if somebody says cat, the first system call, or one of the first system calls will be execve cat, right? Or something along those lines, right? And how do I know if it's a shell process, right? So I know I saw execve, but then what did they run? Well, lists are basically arrays or lists of items. So shell procs, proc name in shell binaries, you have that list up there at the top. Now, if a new shell came out, I could easily update that myself, right? And I could add in Mike shell, for instance. Then that would be shell binaries. So that is lists and macros. They basically allow you to build Falco rules and reuse different pieces of code, avoid really long strings, easier to make modifications, right? Because you're modifying in one place and not all over the place. Now, Falco rules themselves, we ship with about 80 rules. You can enable and disable rules that you can disable rules you don't want to use. You can modify rules. You can override them. So you could take a rule and completely just use all of it except change like one component. You could also go in and you could change the lists. You can modify the rules as you need. You can create your own custom rules. Falco will allow you to load multiple rules files, and those rules files are prioritized based on the order that they're loaded, so that you can ensure that sort of the last in is authoritative. So if you override a rule, you load that in last. That's going to be the version of the rule that we care about. So, all right, we're not doing labs. All right, so the Falco ecosystem. So we talked about by default syscalls, but we also have a plugin architecture, and anybody can write a plugin. I did a talk at Black Hat earlier this year up in Toronto called Nearly Universal Threat Detection with Falco. And it was basically this idea that if you have a known set of events, right, it doesn't matter where they're coming from. If you have an API that you can call to get events and there's a defined format for those events, you can map those into the event format for Falco, and then Falco can process those events for you. So for instance, we had a demo where we wrote a plugin for the Twitter streaming API, or excuse me, the X streaming API. And if, as tweets were coming in, we could build rules. So we could build a rule that said, if the user is Mike G. Coleman, alert us, right? Because we want to know the instant that guy tweets. So that's an example of a plugin that, you could write if you wanted. But we have plugins right now for Kubernetes audit logs, Okta, AWS CloudTrail, GitHub, Google Compute Engine, Docker, all of these different sources. So not only can you, and these plugins come with their own set of rules, right? So I was doing some work with the GCP plugin, and for instance, if I modify permissions on a bucket, a cloud storage bucket, and make that bucket public, that will fire an event warning. That'll fire an alert and say, hey, this bucket is private, right? There's all kinds of different, we don't monitor every service. There's a core set of services we monitor. And the way the Google Cloud one works, just in case you're curious, so you have the log system, and then you create a sink out of that, which is basically a filter. And you can then you can then send anything that matches your filter over to a pub subtopic, right? And then the plugin subscribes to that topic. So your logs are being written, thousands of lines per second or whatever, and we're running them through that filter, and we're grabbing the ones that we care about, that we have rules for, and we're funneling them into PubSub, and then they're being pulled out of PubSub by the plugin, passed into the Falco daemon, and the Falco daemon then, applies the rules to them. So that is how the plugins work. And then there's a piece called Sidekick, and yes, it is all one word. Falco Sidekick basically allows you to extend Falco output to all kinds of different systems, whether they be chat systems or logging servers or functions as a service platforms, or if you want to collect metrics in Prometheus or Grafana or Datadog, if you want to send alerts with PagerDuty, right? If you just want to write it out to a cloud storage bucket or an S3 bucket, you can do that. Sidekick has about 60 different endpoints that you can write to. And it allows for you to build, it allows you to go and build something that fills the biggest gap in Falco, which is that we are a detection engine. We are not a response engine. So we will just alert you, and that's sort of where Falco stops. If you want, and there is a project right now called Talon that's being developed that is a response engine, but it's very early. But this is this is the answer for that, right? So for instance, let's just stay with that. Let's just stay with that example. So if an alert came in from Google Cloud and it told us that a bucket had been made public, what might we want to do? Well, we might want to reset those permissions. So we could go in and we could write a function in Google Cloud Functions using the Google Cloud SDK, and we could write a function that reset the permissions on that bucket, because the alert would have the bucket name, and the Cloud function could go in and permission that bucket for you. So, but you would write, probably 15 lines of Python code to do that. In the example of somebody shelling into a container and installing software, what might you want to do? Well, maybe you want to write some code in Lambda because you're running on Amazon EKS, and you might want to relabel that container. And because of the, Kubernetes can be set up that if it sees a label, it will pull that container out of production. It won't delete the container, and you might want to delete it, but if you want to do forensics, you don't delete it. And that container just stays out there, and then you can go and inspect it and see what they did and figure out how you can prevent it in the future. So that's how you can react to events using Sidekick. So really, honestly, I actually didn't show you how to install Falco, but because usually you do that in a lab. Falco installs either through a normal package manager on the host, or it installs via a Helm chart on Kubernetes. So if you're running on Kubernetes, you just run a Helm chart. Super easy to do. And then, it's basically these same steps, right? Except you would just say Helm repo add Falco security, Helm repo update, and then you would say Helm install Falco and Falco. Right? And that would say install Falco into the Falco namespace, right? And here you can install Sidekick the same way, or if Falco is already installed. Here's the line to install Falco. Helm install Falco, namespace Falco from this Helm chart. and then let's go ahead and set up Sidekick alongside it. Now, if you had already installed Falco with that first line under with Falco, you would run these additional lines up here, and that'd get Falco up and running. Up on our website and our docs, we have a quick start guide for running Falco both on Kubernetes and on Linux, and you can get it up and running and test it like in 5 minutes. So those are up there, and you can check those out. So there is a tool called Event Generator. One of the questions I get is, well, I've installed Falco, how do I know it's working? Event Generator will run a bunch of commands. It'll do a bunch of things that you probably don't want done on your system. So don't run it in production. Run it in a container, run it in a pod on Kubernetes, because it could alter the system. So you want it in those isolated environments. But if you've installed Falco, you can run Event Generator, and it's just going to start kicking out a bunch of events. And then you can check the Falco logs and see that things are working the way you would expect them to. All right. So we've moved from a world where we knew what we were protecting to a world where we don't really know exactly what we're protecting. We have an idea, but there's a lot of moving parts. So using old school static identification doesn't work. We need to be looking constantly in real time. And that's what Falco does. It grabs events either from the kernel or from its plugins. It compares them to a rules engine with rules that you can either take from us, or you can write, or you can modify, and it alerts either out to the system logs, the standard output at the console, or into virtually any one of 60 different endpoints using Sidekick. Falco rules, pretty straightforward. It's just a binary condition, and then you can write meaningful output messages leveraging the metadata that Falco provides. So I just saw that slide. So you can get more information. There is this book. I actually have it. Where there it is right there. Practical Cloud Native Security with Falco. Great book. You can read it in an afternoon. Most of this presentation came from that book. So if you want to dig deeper on stuff I talked about, there's a whole chapter on enrichment that I basically took the information from in there and that sort of stuff. So yeah, that's that. So if you if you have any questions, I have a couple of minutes, but I do have an appointment at 2. I went a little long-winded. Did any questions come into the chat? Nope.
Not so far. So yeah, folks, if you have questions, put in the chat. Thank you, Mike, for this wonderful session. I do have a question, just in the last couple of minutes you have. Is commonly what happens is like typically this questions comes to us very commonly is like how a lot of cloud providers provide security. So how should they distinguish between some of these things which are provided? Like most of the cloud providers provide certain things. So what's the value on top of the customers ask, especially in the cloud context?
Yeah. So in the cloud, from a cloud context, they do have a lot of stuff, right? They're just not generally. The thing that I like about Falco is that you can get it into sort of one place, right? Rather than saying, oh, I'm going to use a cloud specific tool for this, I'm going to use a Kubernetes, I'm going to use a Kubernetes specific tool for this. Falco can handle a lot of those use cases simultaneously, right? It's not a replacement for the integrated tools with your cloud provider. It's just another layer to make sure those tools have been implemented correctly, right? And that's the other part of it too, right? We're looking for those use cases and those patterns. So yeah, definitely not a replacement for those tools, but it's a way to make sure they're being implemented correctly, and a way in a lot of cases to take the output from those tools and centralize it, alongside other alerts that you create for other parts of your system.
Right. Perfect. Thanks, Mike. Yeah, so I think thanks, Mike, for putting those references, and folks, you can reach out to Sysdig. I'll work with Mike to potentially get those slides, and we have recorded. We'll post on our YouTube session channels as well, and reach out to you follow up as well. I just want to take a couple of minutes to talk about the context which we have. That was Mike talking about the overall security, and I think the host for today's event is CloudOpti, which is a SaaS platform with these 4 pillars which I talked about: cost, performance, and security, which was a big topic for today. And finally, compliance. And we look at it holistically in the 4 aspects, and security definitely is a beast. And I think Mike will agree with me, like even Falco and whatever he's covered in an hour and all of these things is scratching the surface. Security is becoming more and more challenging with AI and other areas. So it's a growing area, it's a challenging area, but it's something to be hard to tame it itself, right? If anything, might add to it, but that's what I think, and that's a very important pillar. Number one pillar in my perspective, I think, in terms of all this optimization perspective. On the cloud upgrade perspective, we do have a lot of educational stuff. So if you are looking to get more knowledge about cloud optimization in general, you can go to this cloudopti.com, cloudopti-academy site. You'll go to the site, you'll find these links. There is a free optimization certification of full-on free training, on-demand training, which you can take. And you can take the certification and have that, and we're continuing to add more into this area as well. It's pretty straightforward and simple, no prerequisites are required. But with that, we'll open up to Q&A in a bit, but if not, thank you for your time. And if you have any questions, feel free to reach out to us at cloudopti.com or email info@cloudopti.com. So that's what the session in terms of the thing might have to drop off. I'm going to stop recording at this point of time, and then we'll